On July 20th, 1969, at around 11 p.m., the first man walked on the moon. A friend of mine was old enough to be out on his bike at the time, somewhere in the Toronto area, and he said that as he was out in the nighttime air, he could hear that sound. That whistling sound is called the Quindar sound, or the Quindar tone. And that is a tone that was sent out over the line between mission control and whatever station was transmitting to the Apollo 11 mission, the capsule. And it would actually open up it was like the push to talk on a walkie-talkie, but of course, mission control is in Houston and the transmitter could be in Australia or whatever. So it had to use this tone to open up the channel, and then when they released the button, the tone would cancel channel. As a result, every communication between the moon and mission control had that distinctive high-pitched whistle sound. And he said that he could hear that from just about every house in the neighborhood because everybody was riveted. They were all watching the exact same program, which is waiting to see the first man walk on the moon. Neil Armstrong's first steps on the moon realized a dream that had been put forth by President John F. Kennedy 8 years earlier.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the earth.
Yesterday I went to see the movie Apollo 11, and although I'm very familiar because I'm a bit of a space nerd, I'm very familiar with how the whole mission went about. There was still some really exhilarating moments and some surprises in the movie. The movie doesn't just document a historic event, it's also a time capsule. It's from 50 years ago, after all. And what's striking is just how analog the era is. They show acres of cabinets of what they call computers, but you know that if you added them all up, they wouldn't be as powerful as an iPhone today. The desks that everybody were sitting at had a rotary phone and an ashtray. It was all white men in white dress shirts, a completely different era than what we have today. And it's striking that we were able to accomplish what we were able to accomplish then. That before, when computers were in their infancy, we were able to navigate, communicate, plan, and execute such a complicated mission. There were so many components, and so many of them had to go right and did go right in that mission. It's really remarkable. All the way from the 3 stages of the launch, the docking and undocking maneuvers, landing on the moon, leaving the moon, docking again, flying home, the capsule burning through the atmosphere. All these things were tested and proven over multiple missions that led up to that day. Think about all the steps that go into that. How many things that as yet had never been attempted, let alone done successfully, when President Kennedy said it was going to have to happen within the decade. The way NASA went about it, I think, was a perfect example of the iteration we talk about in design thinking and lean startup. The idea that you don't go for one big swing. What you do is you identify the smallest step you can take that proves or establishes a way of doing something. You get that right, and then you go on to the next thing. You had Mercury that flew men into space for the first time and proved that the launch vehicles were capable of it, that life support could be sustained in orbit. Then there were the Gemini missions that were more complex, more involved. They established that we could stay longer in space. There were docking maneuvers that paved the way for Apollo. Kennedy's decision to send men to the moon was not only inspirational, and it gave humanity a sense of a different place in the universe, that it was free to move beyond the confines of the Earth, but it was also a Cold War play. It was a move to demonstrate the might of America in the face of what was then seen to be an advancing Soviet threat. And you can see that in this movie. The amount of resources that were marshaled to send men to the moon are just incredible. The rocket itself, the whole Saturn V rocket that included the Apollo mission, was over 360 feet tall. This is an enormous undertaking. They did a great shot of a helicopter shot coming around as the fully assembled Saturn V and Apollo were being wheeled out to the launch pad on this enormous tractor. Not only was the rocket enormous, but the team supporting it was enormous as well. They showed many shots of, as I said, hundreds of people that were involved in the launch, let alone the people who built and designed the rockets, but just who were on station making sure that the launch went well. And then the other side of it, the flip side, is the military involvement. The Navy had to have ships on station waiting for the Apollo 11 capsule to return to Earth, splash down, and be recovered. So it's not something, it's not a trivial undertaking. And in fact, at its zenith, NASA's budget was just over 4.4% of the nation's budget, the federal budget. The Space Shuttle also introduced many new technologies: the solid rocket boosters, the disposable tank, mounting the ship alongside these three components, having a reusable orbiter, having reusable engines, having the heat shield made of glass tiles. All these things were entirely new technologies, and yet rather than approach them piecemeal, rather than try one flight with one technology and then move on to add more technologies, the planners of the Space Shuttle were bound and determined to do it all in one go. As a child, I had a Space Shuttle model. I built it. It was one of those plastic models with the model glue, and I put it together, I painted it, I put the decals on. I was in love with that spacecraft. It's a beautiful thing. It's an incredible feat of engineering, but it had many inherent flaws. The men and women who poured their heart and soul into designing and maintaining the Space Shuttle undoubtedly were extremely capable and dedicated and cared deeply about the mission and the people who flew in the Space Shuttle. I believe that they were cornered by an overly ambitious set of specifications or requirements and a limited amount of funding. So there was only one chance to make this work. That was to build the Space Shuttle as it was originally conceived, even though there were a number of flaws in the design of the Space Shuttle. The Space Shuttle did not have an abort sequence. There was no, or an abort escape sequence. There was no way to eject the crew from the Space Shuttle in the event of a disaster. Contrast that with the Apollo and all the other capsule rockets. Each capsule, the Gemini actually had ejection seats, but the Mercury and the Apollo had an abort tower, a rocket fixed to the top of the capsule that could lift the capsule away if the rocket started to get into trouble. There was no such mechanism in the Space Shuttle. And also the Space Shuttle, the orbiter itself, was sitting alongside the solid rocket boosters, which are not throttleable. You can't turn them off if they're already on. They do have a tendency, as we know, to leak at the seals. And then the other problem was the very fragile heat shield that the Space Shuttle had. Having that alongside the fuel tank, which contained liquid oxygen and therefore accumulated ice on the outside while it was sitting on the pad, that combination proved fatal to one of the shuttle launches, and the SRBs, the solid rocket boosters, proved fatal to another one. The point of this is not to criticize any of the individuals involved. The point is to reflect on the challenges that come from going for one big swing as opposed to iterative effort. And that's what I find fascinating about all of this, is it comes full circle to the idea, thinking, principle of iteration. Don't try to do everything in one go. That applies to your business, that applies to your life, and yes, it applies to rocket science. Thank you for watching another episode of Repeatable Genius. If you enjoyed this, please click like and subscribe. I'll see you at the next one. Thank you.